everyone, I'm Chenhoa. I'm a first-year PhD student at UCLA with Professor Harry Burden. So my topic today is about the effect of the number of quantum motion and probability model misclassification on the estimation of certainty in fragility analysis. I just want to give an example of what is estimation of certainty. So our common practice that first we select quantum motion and run structural analysis and get structural responses and different hazard level from which you can get the so-called empirical distribution. So from the empirical distribution, you can so write down the log likelihood function from which you can get the estimates of theta and beta, which are two parameters in the log normal distribution, by maximizing this log likelihood function. So yeah, so that you can drop the white light here, I call it as the best estimate from the your log likelihood function because just the result from your MLE. So this is a question here because most of the prior study just stop here just to show you the best result, the best estimate. So I'm curious about what about the estimation uncertainty around the MAL estimators. So the question continues, what if I change another quantum motion set, but I just maintain the number of quantum motions? You can definitely get a different estimate, right? You can get, for example, you get a different quantum motion set, you definitely can get a different estimate of the parameters. So sometimes this difference is very large, which is very unacceptable. So yeah, so to quantify the estimation uncertainty, you can use different measures. A very smart choice is you can use the so-called confidence interval. So this picture shows you two measures. One is from the so-called classical measure, and another one is called the robust one. And the difference is the robust confidence interval consider the misspecification potential, so that you can see the gray area is much wider than the red one. Means we have a great evidence of we have detected the model misspecification. So I also want to mention in different seismic codes like Caltrans or ASCE and FEMA, they have also specified the minimum number of quantum motion, and this also need to calibrate in our study. So all the things lead to our object in this study. We would like to use the robust method to quantify the estimation uncertainty, and want to quantify the effects of a model misspecification on both the code-based design and the risk-based assessment. I want to figure out how many quantum motion are enough to lower our estimation uncertainty to a target. So this is our bridge model. We use OpenSysPy, and thank you for Professor Scott for your guidance. And we consider bridges designed in different areas with different capacities. And this is our PSHA result. So this is our procedure in our risk-based assessment. We use the multiple stripe analysis with 6 stripes, and we use a different number of quantum motion in each stripe to match the conditional spectrum. And we want to quantify the effect of a different number of quantum motion on the estimation uncertainty to the mean annual frequency of exceeding a different limit state of bridges. So this is just our result here. I'm just escape this result. To just show you some basic observations from the result, we definitely observe the increased estimation uncertainty in the presence of a misspecification, and this leads to a greater number of quantum motion to achieve a target. Yeah, because the time is very limited, so I'm just stop here, but you are more than welcome to stop by the poster session. Thank you.